With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, in regular triangular prism, the distance from the center of the one basis to one of the vertices of the other basis is E. The altitude of the prism for which the volume is greatest is. The options are E by 2, E by root 2, and E by 3 and E by 4. Yeah. So in this question, given that there is a triangular prism, so we can draw the triangular prism like this. And this way we can draw this, and just we have to draw the triangular prism. Just 1 second. We can draw the triangular prism like this. Okay, this way. Just we can see that from here. So we have to erase this. Just 1 second. So this is the triangular prism. We can achieve. This is the triangle. We can see from here. This is the triangle base, and this is also this is the triangle, and equilateral triangle is this. Clear? And it is also given that the distance from the distance of the one base of the one vertices of the other bases is E. Means let us consider this is the base of the first triangle. So this distance is given from here to here. Any vertices we can take these vertices. So this distance is given. Let us consider altitude of this height is h. Clear? And this distance is what we can take d distance. Clear? And this is given, that is E. Now this is the 90 degree, we can see that. This is the 90 degree. So we can find from here d. So we can find this is equal to E square is equal to h square plus d square. So d square equal to, we can write that is equal to E square minus h square. So from here d we can write d is equal to root under E square minus h square. Clear? A square minus h square, we can write d is equal to this. Clear? Now we have to draw this triangle separately. This triangle. So if we draw the triangle, this, and this is the equilateral triangle. So if you draw this, then we can see that this is the point, and this is the D. And let us consider side of this triangle is what? E. So we can A we can take, and we can take A from here. So also we know that this is the ratio of this is the equilateral triangle. So we consider this the centroid in center, and also center are the same point. So this ratio, as we know, this we can write from here. So this D 2:1. This is the 2:1. So this is the D. So this is equal to D by 2. We can say from here. Now we can see that from here, this is the right angle triangle, and this distance is what? A by 2, and this is also A by 2. So A by 2 whole square plus this square D by 2 plus D whole square is equal to A square. From here we can write this triangle, we can write D plus D by 2 whole square plus A by 2 whole square is equal to A square. So from here we can find the A value in terms of the D value. So we have to solve this. So this is equal to d square plus d square and divided by 4 plus 2d square plus a square divided by 4, and that is equal to a square. So we can separate d and a. So this is equal to 4. We can take LCM. So 4 d square plus d square plus 8d square and divided by 4 is equal to, we can write from here, this is equal to a square minus a square and divided by 4. This. So this is equal to 4 plus 8, 12, 13d square, and here we can say 4 cancel. This is equal to, so we have to find from here, and this is equal to, we can get relation between a and d, and this a is equal to, we can get, this is equal to root 3 into d. After solving, you will get this. Clear? Now, area of the equilateral triangle, as we know, area is equal to area of the equilateral triangle. Area is equal to 1 by 2, sorry, root 3 and divided by 4 into a square. And a is this, so root 3 and divided by 4, a square. A square means root 3 d whole square. So this is equal to, we can see from here, 3 root 3 and divided by 4 into d square. Clear? So d square is equal to, we can see from here, d square is equal to, earlier we have found L square minus h square, means E square minus h square. So this is equal to 3 root 3 and divided by 4 E square minus h square. This is the area. Finally, we have to find the volume. So volume is equal to, as we know, area. This is equal to area, base area into height. So this is equal to, base area is equal to this 3 root 3 and divided by 4 into this E square minus h square, E square minus h square into h. This is the base area, means volume is this. So this is equal to, V is equal to 3 root 3 and divided by 4, and this is EH minus HQ. Now for maximum minima, we know, for maxima and minima, for maxima and minima, for maximum we have to analyze from here. So for maximum, we know dV by dH, dV and divided by ds will be equal to 0. Clear? So after differentiating, we will get dV by dH, dV and divided by dH is equal to, we can write, this is equal to 3 root 3 and divided by 4, and this is E minus 3h square. This, clear? From here we can find the h value. So h is equal to, we can say, this is the E square minus h square. Here is the E. So we can write E square from there. So this is the E square here. So this, from here we can see that, so this is equal to 0, means E square minus 3h square is equal to 0. So h square, we can say 3h square is equal to E square. This is 3. So from here h equal to, we can find E and divided by root 3. Now how we can check? This is the maxima. This h is the maximum point. So for this we have to find the d2 v by dh square we have to find after further differences. So this is the required answer for this question, but we have to check this is the maximum point or not. So we have to find d2v and divided by dh square. This we have to find. So we can see from it, this is the constant. So this is equal to 3 root 3 and divided by 4 and minus 6 into h, this, and h is equal to this E divided by root 3. So this value is the less than 0. So this point is for the maximum. So we can see that for maximum value, h equal to this E divided by root 3. Clear? Hope this answered the question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.